So they're like polynomial functions, or exponential functions, or trigonometric functions that, like cosine and sine. Cosecant would not work with this because its derivatives are funky. It's not related to its own derivatives. So all of the ones that work are somehow related to their own derivatives. Polynomials are not like directly, but they have pieces, parts that would be like terms with other derivatives of itself. Does that sound understandable?
Yes.
So like anything whose derivative is not really like terms with any part of its original, and down the line, however many derivatives you have to do, won't work with this. So that's why we have 4-6, which we'll do after this. 4-6 is what you do when you have something here that doesn't work with the method we're about to use here. Is everybody still with me? All right. 4-6 is one of my favorites. We'll see what happens. So what would you guess the answer should look like?
Sine something.
Could be, but it could also be
Cosine.
cosine. So it's going to be some linear combination of sine and cosine.
Cotangent, just out of curiosity now.
Huh?
I'm going to say cotangent for some reason.
Don't say that, because that doesn't make any sense. Let me make sure you guys understand. The answer certainly could be some kind of multiple of cosine. That by itself, does that make sense? Yes. Yeah. But it could also be some multiple of sine, to be honest. Okay. In general, right? So I would guess the solution to have a form of a cosine x plus b sine x. So this method is really just so direct. It just says, guess what the answer looks like. Now, if I make an incorrect guess, if I leave out some options that end up being required for the answer, you're going to get to a point where it just doesn't make any sense. You're going to equate coefficients, and there won't be something they're equated to, which is not going to work. Okay. So y prime then, of course, to match up my derivatives, y prime, just to do this very quickly. Gather sign. And then y double prime. Okay. And now if I throw this stuff in there, I get negative a cosine x minus b sine x minus a cosine x minus b sine x equals 2 cosine x. Okay. So I got my guess. I did my derivatives. I plugged stuff in. And now it's just a matter of equating coefficients. Now, hopefully some of you guys realize, because of the relationship in the beginning, I pretty much could tell it wasn't going to involve a sign, but right, there's no signs on this side. But if I have all three orders, then there definitely almost has to be a sign involved. Right? And yeah, that's where your coefficients can get kind of gross, but oh. So here I end up with negative 2a has to equal what? 2.
Yeah.
And negative 2b, of course, has to equal
0.
0. So b is 0. I don't need any signs. But it's better to have more than less. And then here,
A is negative 1.
a is negative 1. So then your answer is going to be,
Negative cosine.
this is yp, right?
Yeah.
Negative cosine x. Now how do I find, what else do I need to complete this? I wanted to focus on this because this is the new part, semi-new part. Now, of course, I need yc. And how do I find yc?
Using the u times.
Yeah, you normally start with yc. I just wanted to focus on the new stuff. Yeah. What do I write down to kind of start looking for yc? What do I write down? Where does yc come from? What's that c mean? It's coming from where? It's the things that make the differential equation become 0. So I write down the associated homogeneous, the right? And again, the idea is if I include the parts that make this 0, it's not going to get in the way of this thing that makes it equal this. So the associated homogeneous will look like this. What does its little dude look like? Its little auxiliary. So many A stuff here. Let me stop here for a second. In general, when you have a non-homogeneous DE, you do the associated one first. You get the YCs. Then you move on to whatever procedure you have to do the non-homogeneous part, right? So we can do this one for constant, coefficient, linear, homogeneous DEs, right? That's what we're about to do here, right? This is for certain functions. I can do the YP assuming the form of the answer for certain functions, certain nice functions that play well with its own derivatives, right? So how do I write the auxiliary equation for this?
M minus squared minus 1.
M squared minus 1. Of course, that's M equal
1.
plus or minus 1. So then I get YC is C1e to the
4x.
x plus C2 e to the. So then Y equals C1 e to the x plus C2 e to the negative x minus cosine x. So if you plug this in here, the differential equation operating on these is 0, plus the result of this will be that. So the end result is just 2 cosine x. The 0 parts don't mess with it. That's why this superposition principle between the YCs and the YPs makes sense. It's beautiful. Okay, it's my hope. Okay, so let's take a step up. Let's do a level up from this.
Makes a lot more sense.
So everybody got what they want from this guy?
Yep.
Okay. So here's the next kind of step up. Yeah, let's do the one that's on here just to keep it within the bounds here.
So your y is just a linear combination of your yp and your yc?
Say again, sorry?
Your y is a linear combination of your yp and your yc?
Yes, good. I love it. The y is the solution to the whole DE. So it's the yp which makes the answer work, which makes the f of x show up, plus the parts that make it 0 because it's not going to mess with that. And that's the yc parts. Now, who has an idea what the form of the answer should be for this? And actually, here's why you do the, well, that's not here why, but what would the, let's look at the associated, let's do this in the right order. Is the
So m squared plus 2.
Yeah, so you get m squared plus 2m equals 0, so you get m plus 2 equals 0, you got m equals 0 and negative 2. So then you get yc is c1
0 is
C1.
1.
plus c2 e to the
Negative 2.
negative 2. I love it. Okay, cool. Now, there would have been an issue if one of the answers to this would have been x e to the x. So we're going to look at one like that here in a minute. Because then I can't assume a form of this as x to the x, because anything times x e to the x, any constant, would make this 0. It won't make it equal 9x e to the x. There's no chance. Shit. So we actually do the same thing we did for repeat roots. We multiply by as many powers of x to lift it out of the chances that any part of it will make it 0. I don't know if that made grammatical sense, but we'll do an example like it. Right here, we're not in trouble, are we? No part of this is here.
Yeah.
Thank God. So I can assume the form just directly. Well, what do you guys think? If that wasn't there, the form would just be a e to the x. Yeah. This is not ax e to the x and stop. That's not good enough. So if it would have been 9x squared, you would have had to assume ax squared plus bx plus c e to the x. I like it. If you look at the little table in the chapter, it's really good about showing you some specific examples and where they go. You can make some generalizations based off of it. I can't remember. So it's 4.4, bottom page 146. So if you have your book, if you look at like example number 9, it says x squared e to the 5x. I would have to assume ax squared plus bx plus c e to the 5x. Okay, maybe. So then I get, let's try to do this one. Let's see how we can do here. Y prime would be, and you can break this up if you want to. Ax e to the x plus b e to the x. So y prime is
E to x times
I don't know which way you want to do this. So it would be a e to the x plus ax e to the x plus b e to the x. Is that cool? Good old product rule here.
Yeah.
Which table?
Table 441.
Yeah.
Yeah. If you look at number 9, it's sort of like this one, just even one level up.
Oh, gotcha.
Yeah. It's the sand and that's super sand. And then here,
A e to the
a e
x
to the x
plus
plus a e to the x
yeah, so yeah.
plus
A
a x e to the x plus b e to the x. Woof. So we cool. I put that 2 there because you picked up another. And then you throw it in. It's really nice. I mean, unless you hate equating coefficients, which I don't understand you if you do, because that's like, please. Don't associate it with partial fractions. This is much better. It just uses that one piece, which is really easy. Equate your coefficients. Ooh, right? So we get 2a e to the x plus ax e to the x plus b e to the x plus 2a e to the x, so 4, is that okay if I do that? Are you guys going to go insane if I do that? Let me not do that. Plus 2a e to the x plus 2ax e to the x plus 2b e to the x equals 9x frickin' e to the x. Okay. So far, so good? I mean, you've been doing this since almost the first day. I mean, the first day we did a verify problem. Well, now we're assuming the form and basically doing a verify problem in a way. Not verify, though, it's getting what A and B are in this case. So let's see, what do we got? 2A plus B plus 2A plus 2B has to equal what? Those are my coefficients of e to the x. Do I have any e to the x's over there?
1.
Do I have one? No, I have 9x e to the x's.
Oh, that's different.
I don't have any e to the x's. So it has to be 0. So that means a 4a plus 3b is 0. Is everybody with me so far?
Yeah.
And now all my x e to the x stuff. So a plus 2a.
3a.
I think that's it, right? That's all my x e to the x stuff. So 3a has to be 9x. Oh, gather x. 3a has to be 9. Just the coefficients.
So a is 3.
A is 3. So B is 4 times 3 plus 3 times -4. All right? You can rise above your algebra old self. Shed that shit and start just looking at things more directly. Or not. So then what's the answer?
1 equals 2. 3.
So just look back at your assumed form
3x.
and fill in what you know. No.
3 minus 4 e to the
Well, that's that. That's yp, right?
yeah.
So now what's y? What was that? Oh, that's here's okay. Y equals c1 plus c2 e to negative 2x plus that thing 3x minus 4 e to the x. That is your general solution. Yes, sir.
Can you go back to that long?
This guy?
Yeah.
Yeah.
What happened?
So all my e to the x coefficients have to add to be 0 because there is no e to the x term over here. All my x e to the x coefficients have to add to be 9 to make this true. So that's where those two equations came from. And thank God I have two equations because I have two unknowns. So this is just saying that everything in front of e to the x must equal 0 because how many e to the x's are over there? None. These, the coefficients of my, oh, that's this. Sorry. Why do I have 0 here? Oh, there it is. I'm looking at these like these are 3. Here's the one that's my coefficients of x, e to the x. They have to add to be 9 because that's how many x, e to the x's I have. That's that same step with partial fractions.
And that long thing is after you plug in the derivatives.
Yeah, that came from just plugging this stuff in.
And rearranging the variables to match terms.
That should feel very familiar. And also very nice. Compared to some of the stuff we do,
No.
that's nice.
Too much work.
So let's do, all right, let's do one more example where we have to be careful about the YC stuff. Just because it's a good idea. Let me find one that does that real quick. Maybe not real quick. Where are you? Oh, here we go. All right. Okay, perfect. Okay, this is a nice one. And this will generalize the idea from this. Does everybody got what they want from there?
No.
Sorry.
It's all good.
So here, let me write the problem up here. Oops, so plus 4y. YC plus YP. So if you do your or should we call it I don't know. How you want the emphasis on that? Yeah?
That's how I feel now.
I don't know if I could stand myself doing that the whole sentence. I don't know. If you do your blah blah blah. I can't spell the letter H. If you do that, what's it look like in your auxiliary? Let's just jump to the auxiliary. I think most of you guys should be able to do that by now. You gotta be careful. In the next section after in 4.7, there will be something very similar to this, but it's not going to be a perfect go-between. It's going to have a little bit of a hitch in it because it's going to be based on x to the m. And when you do x to the m derivatives, you have m, and then you have m minus 1 coming down. If you think about, oh shit, it's going to throw your stuff off a bit. People make too many assumptions about what works and why. But for this one, we know we're doing e to the x, which is beautiful. It becomes a very simple auxiliary. What do you get?
M squared minus 5m plus 4. M equals
0.
4.
Yeah,
M
so
equals
the is making this homogeneous. It's finding your YCs, and then we'll focus on our YPs. So, of course, how do you factor this guy?
M minus 4, M minus 1.
Beautiful.
M equals to 4, M is equal to 1.
Lisa, just take it off. And then what's your YC?
C1, E2, 4,
Which means any constant times e to the x, if I plug it in, what will happen to this dE? It will become 0, no matter what. So I cannot assume the form of my answer to be a e to the x, because we just said any constant times e to the x is going to make the stupid answer 0. Shit. So this is related to, and again, I kind of gave it away earlier, but what you do is you take what you normally... You take what you normally would use as a guess. Oh, shit. Anyway, 4 or 5 is correct. And so my guess would normally be a e to the x. And you multiply by as many powers of x until you get it out of the realm of being a problem. Let me try to say this again. So if I had some dE that was equal to x squared e to the x, and I do my YCs, and I get C1 x squared e to the x. Oh shit. So I normally would guess a form ax squared plus bx plus c e to the x. So I have to multiply this whole thing until none of them have that problem. So I'd have to multiply. If I multiply by x squared, this last one still has a problem, right? So I'd have to multiply this whole thing by x cubed. And I think, I can't remember where in the book they summarized what I just said. Here we go. Example 7, right below example 7. And I can't remember if I put that on the actual... Oh, well, there you go. It's also on the back of this, case 2. If I would just look at what I did, I would remember I did something. All right. So you guys get the no matter what, if there's a piece of this that has a problem. So if it would have been this, then I would have guessed that. I would still have to multiply by x would not be enough. I have to multiply x squared. So it'd be bx cubed plus cx squared e to the x. That would be my guess. I have to lift everybody up until none of them have the problem. Until none of them have the piece that makes it 0. I really want this understood. I can't assume an answer to be ax e to the x plus b e to the x, because this piece would make the dE 0. It would never make the dE become this. So to take care of it, I multiply this whole thing by enough x's until no part of it has that issue. And if you look at example 7, in red at the bottom of example 7, they capture it, and I think I have basically the same thing on case 2 on the back of this. So, here, what do? I already did it. I multiplied by enough x's until I didn't have that problem, right?
Yeah.
Wasn't that big of an issue here. And then you just do the same thing we did earlier. Y prime plus a e to the x plus ax e to the x. Throw that stuff in. I mean, that's... Now, if you didn't do that, hopefully it's very obvious that it would never work. If you assume y equals 8 e to the x, you know already it's going to make it 0. It's never going to... You have 0 equals 8 e to the x. That's okay. That's no good. 8 e to the x can't be 0. That's a problem. So that's trying to tell you, oh shit, you left something out. You don't have the right form. It's not going to match. And normally that means you forgot to multiply by whatever number of x's you needed to multiply by. This feels a lot like the repeated roots, because you multiply x when you have a repeated root, which is sort of what it is. Not really. I don't know. You guys want to do this one, or is that? Yes? Okay. So you get 2a e to the x plus ax e to the x. Minus 5 times this, so minus 5a e to the x minus 5ax e to the x. Plus 4 of these, so plus 4ax e to the x equals 8 e to the x. So if I look at all my x e to the x coefficients, what must happen with all those being combined?
Must be 0.
And we'll look at this. A minus 5a plus 4a is 0. That's nice. I'm not saying it's always going to happen, but that's nice. And then what has to happen with these guys?
Equals to
Oh, get out of there. Shit. It's just these two, right?
Yeah.
So negative 3a has to equal
8.
8. All right, 2a minus 5a.
So A is 8/3.
A is equal to negative 8/3. So your answer, your yp will be negative 8/3 x e to the x. And then you add that to your yc for your whole solution. I like it. Again, it's simple, but you got to do some of this to make it become more of a process that you know really well, more of a recipe kind of thing. Okay, I like it. Okay, all right. I think there's enough time for this very funky thing. Okay, so 4-5 is extra credit. You can look through that if you want to. 4-6 is really neat. There's one step that I was really excited that my class last semester had a problem with, and I'm like, fantastic, you should have a problem. So I'm going to go through it and see if you guys pick up on this. I'm not saying there's an issue with it. I'm just saying, why would you accept it on face value? You should go, why the shit should we do that? And then I'll say, oh, okay, because of this. We should never accept what I say on face value. Everybody got what they want here? Okay. So this method in 4-6, I need to lay the groundwork for this today before I lose you for the spring break.
Either way, you're gonna lose it,
You're
right?
physically here, right? Mentally, I don't know, but physically here, I'm going to count that. It's on the YouTube, it's on the internet. It's variation of parameters. So let me see, how do I want to start this out? Here we go. Perfect. Okay. It's going to get a little bit weedy in here. We get in the weeds, right? So a lot of little details. But there's some major kind of assumptions that are made, and I want them to really make sense why we make the assumption, why it's okay to make the assumptions. So I think I've shown you this form before. This is your second order linear. Non-homogeneous, yeah. So if you did the you would get, how many parts would you get? 2. So you get, like, let's say you do it and you get C1Y1 plus C2Y2. Is that cool? Okay, so that's the general idea. You have to find 2. I like it. Now, here's the thing. So it's very similar. It feels exactly the same as my reduction of order idea. Because what we do is we assume that an answer to this is going to be some, I like the way they say it, so it's some functional coefficient multiple of these. So just like we did y equals ux, now we're going to do y equals u1 y1 plus u2 y2. And now you can see probably why it gets a little bit in the weeds, because when you start doing derivatives, you've already got 2 sets of product rules there, and then you do another derivative. Yeah, it gets really exciting. So just bear with me. I might just skip a few steps here, but oh boy, oh shit. You look appropriately excited.
Yeah.
All right. I guess that's how it looks like.
It's not a lot.
So if you do y prime,
You one y prime.
yeah, we'll just do it real quick. Right? So you don't even maybe have to write this down necessarily, unless you really, really, really want to. All right, let's see if we can do this in a semi. So it'll be plus, let's see if you guys can stay with it. It'll be plus u1 prime, y1 prime, but that's the first part of this one, right? So I'll get plus 2, u1 prime, y1 prime, plus u1, y1 double prime. I like it. And now I get something, now notice how these are the same as these, just with 2's. Right? So I'm going to get the exact same thing except with 2's. You guys see that? So plus u2 double prime y2 plus 2 u2 prime y1. Together 1 prime plus u2 y2 double prime. Yes, ma'am.
So use a function, yeah?
Yes, totally. C is a constant, which is a function, but no. This is a true function of x. And again, what's the idea? Now this is a really neat idea, because what we just discovered a minute ago is that when you do a homogeneous DE, you have to have linearly independent functions. But now it's an extra level for the YP. They definitely have to be linearly independent, because otherwise it would make the DE become 0. So now I'm saying that whatever the YP is has to be linearly independent from both of these. You guys get that? That's the next level up. And I can extend this whole thing to 3rd order, 4th order, 5th order, 28 millionth order. Right?
Infinity.
However many dimensions you want. Or don't want, but still have to work with. We're not going to work with. Okay. Now here's where it gets.
Is there any slick and fast ways to do this?
I'll tell you what. Let me
No.
just.
No shortcuts.
This is the step where you write very carefully. You try not to lose anybody. Can I just step? I think you'd be okay with me stepping over that a bit and showing you where this kind of leads to. I would plug all this stuff in, right?
Oh, messing
Yep.
up, yeah.
And then I'm going to have a P and a Q. I'm not going to put the of X. Is that cool?
Yeah.
Okay.
Okay. So eventually, if I collect stuff together, I'll end up with. Let's see, what order do I want to put this in? Yeah. Oh, okay. All right. U1 times y1 double prime plus py prime plus q y1 prime plus qy1 plus U2 times the same stuff. Okay. So it's just collecting all my U1 stuff, all my U2 stuff, and just factoring those out.
Okay.
Okay, I'm going to say something about this in a minute. Let's see, what am I putting next? Blah, blah, blah. Plus now my P stuff. And then just, oh, let me see. How do I want to say this? Okay, let me put this down there. Yeah. Okay, all right. So you can see all those parts there, plug it in there. You can kind of and just reorganize them. Okay, and then some final parts here. Oops, did I have that one already? Oh, well, okay. I think, no, I don't have that one already. That's right. Y2, U2 prime. I like it. Woo! Let me make sure that's everybody. Bam, 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 bam. Good. Okay. Now, and again, I mean, this is a step we could all do if we desperately had to, right? You could be careful. You could plug all this shit in. You can reorganize stuff. You'd have to have a little guidance maybe as to why we reorganize the way we do. But you guys notice something interesting about these two things? What does Y1 do when I plug it in? Where did Y1 come from? Yeah, it makes it 0. So that's 0. That's 0, this whole thing. Right? So those are both gone. And again, that's what reduction of order does. That's why it makes sense. If I put something in that's related to a function that makes it 0, then parts of it should go away. And that's why parts of it go away when I do that reduction of order. Right? Parts of it went away, thank God. Still kind of gross. Now, what is it? These guys here, yeah, these guys here are very interesting. I can rewrite those. All right, I appreciate your patience. Oh, Shay. So, does anybody notice something about these?
Particle. Isn't it particle? dx of y1 times u? Y times u?
Yeah, what am I doing? It would be
Yeah.
y1, u1 prime,
Yeah,
right?
prime, yeah.
So it's the derivative, it's a product rule of y1, u1 prime. You guys see that? Okay. And of course, this would be the product rule of y2, u2
I didn't
prime.
get that part.
Because those are basically the same thing, ones with ones, ones with twos. Now, of course, that's not like immediately obvious to a lot of us, but hopefully you guys can start to look for that. And then you got these little dudes at the end. And that equals f of x. Where'd it go? Woo!
So this is just the only test question we're having, right? Just this.
Now, now listen. I think I said this earlier. Didn't I tell you not even to write this down if you didn't want to? Because what are we doing right now? We're deriving a process. This is not the process. You will not be doing this for every problem. My God.
Is this a proof then? The proof that
This
we
is
do? Or-
This is the process behind what we do. And the reason I'm okay with it is because what we do actually encapsulates the idea behind where we are now. All this stuff is really kind of busy work in a way. I mean, I'm sure that's why you feel, but it's a bunch of crap to keep track of. Can you keep track of it? Ooh, you know. Okay, so I understand how some of you might feel about this kind of problem, but that's why we're going to make a process that goes straight to the heart of the idea. Now here is where neat things happen. All right. I'm going to propose something, and then I want to see what you guys think, and I'm kind of giving it away here, but
I'm going to deny it.
let me see. Do I need this anymore? No.
No.
Do you notice anything that's repeated up here, like a little phrase that's repeated.
The P and the D.
Yeah, the stuff inside of here and the stuff inside of here
Yeah.
are the same, right? So what I propose is, let's assume, ooh, that's an awesome word. I thought you and me, right? Assume y1u1 prime plus y2u2 prime equals 0. Now, let me go back. Of course, this is the part I wanted to go back to. Remember we assumed that y is u y1 plus u y2, right? That's the answer. That's the yp. Everybody remember that? That's what got us going. What are the u's? u1 and u2, I'm sorry. U and u2. They don't have to be the same. What are the u's? There's some function of x that causes the yp to show up and keeps these guys independent from each other, right?
Yeah.
There's an infinite number of things that could be.
Right.
Because it could actually be something that's got parts of the y1 and y2 in it. So it would just kind of get sucked in. If I have c1, y1 plus, and this guy's got 3y1, well, I'm just going to suck that together. So there are an infinite number of choices I can make for this. So I'm going to pick freaking 0. Now, I could, last semester, I think I might do this anyway. I wrote out and copied, and who the shit knows where it is now, me doing a whole problem, assuming something else here. Just anything else. Because it's really neat to see what happens between the two. And this is a part that teachers very often, my teacher would go, we'll see why we do this later, and then we do it, and it was easy because we did this, and it still didn't answer the question, why the shit we did this? Why are we allowed to do this? Because there are an infinite number of U functions that would work. They're all related to each other. They just have pieces, parts that they don't, that are, like I said, that would be like terms with some of the stuff in the y1 and y2. So it just gets sucked into it. So if you see an example of one where we don't assume this is 0, then you can kind of see how that works concretely. Yes?
Can you tell us like another one that might work?
No, you need to understand. Anything you put there
It will
like
work.
will work.
As long as it's within the bounds.
Anything
And
you
know
put
what
there.
like.
Anything. Because whatever you put here, now watch. What's about now? Let's look at the next step, and you start to see that it isn't as flexible as it feels right now. It's remarkably flexible. You can put anything here. But what's the next step? How many unknowns do I have here? 2. How many equations have I written down so far? 1. Okay. So the minute I say that this and this are 0, then this
This one.
is 0.
Oh.
So which means that y1, u1 prime. Did I write this? Oh, did I miss something? You crazy Jeff. Oh, yeah, I did. Here, I'm sorry. So prime, of course. Otherwise, it'd be the same damn thing again. Now, why does that equal f of x? Because I assume that this whole part goes to 0, right? Now, if I assume it equals 1, then I'm going to have to plug a 1 in here, and then that's going to affect what this equals. Do you guys see what I'm saying? There's a bit of give and take there. If I make this something other than 0, this is going to be some f of x minus or plus some adjustment because of that. So right there's a little bit of a, okay, you start to buy into it a little bit. Okay, this gets adjusted then if I choose something else here. But why do we choose this? Because we can choose anything, and that makes it the easiest. Now, I told my students last semester this, and I didn't really have time to try to find an example. This is not always the best option. To be honest, it kind of depends on what's in the equation. Sometimes you can be really clever about what to pick here. It's going to make your work easier on the next level.
Like, can't you repeat
Now,
that?
can I find an example of that easily? No. I remember doing one sort of like that in the book that I had, 20 years ago. And I don't know if I still have it. But anyway, that in general is the best because that immediately kills these two parts. Fantastic. But I want you to realize, if I assumed it was equal to x, is this hard to do? D by dx of x? No. Whatever the shit p is, multiply by x, is that hard? No. Right?
Yeah.
Okay. So not horrible, but the next level is going to make it, you understand why. So how do I solve this system of equations?
Eliminate.
A very, very obscure thing I could use. And you could, maybe somebody would suggest to set up the the matrix for this, right?
Oh.
But we can be a little bit better than that even, and it will actually answer a little bit of a question from earlier. We can look at something called Kramer's rule.
I remember that movie.
Now, the really nice thing is we're going to use Kramer's rule to arrive at a shortcut. I don't know if anybody ever heard of Kramer's rule, but it's not Kramer versus Kramer. It's not. Yes, you've heard it.
You take the determinant of like 3 different times, and then you do something where you divide and find solutions.
If you replace, like a matrix for a system of equations, the first column is x, second column is y, third column is z, right? So if you put the answer column into the x, replace the x column with the answer column and do the determinant, you'll get something related to the answer for x.
Oh.
And you keep going. Yes, it's a very nifty, very not used rule, right? This is one place we definitely use the shit out of it. So the Wronskian, just remind me, what's the Wronskian in general? All right, there's the Wronskian. Now let me define Wronskian sub 1 to be like Kramer's rule for the first column. So W1, how you doing there, little dude? All right. Will be plugging the answer column into the first column. Just replace the first column with the answers. Now please understand, we are still talking about deriving the process. This is still not the process yet, okay? That was exactly what I would have said if I was a student in this class. W2 will then be, amazingly enough,
This one too. The one.
so what does this Wronskian equal? You just do the determinant, right?
Right.
Yeah. So it'll be 0 minus, so it's minus y2 f of x, right? And this one will be y1 f of x. Okay. And now, and finally, what is it we're trying, from the system of equations, what are the 2 variables, the 2 things we're trying to solve for? And not variables, but in that parlance of system of equations. What are the 2 things we're solving for? U1 prime and U2 prime. Those are my variables, right? My functional variables. All right. You guys cool with that? I mean, there are the y1, y2, and y1 prime, y2 prime are knowns. Mm-hmm. They're like 3 and 7. They're knowns, known functions. These are the unknowns. So with all this shit, if I can figure out what u1 prime and u2 prime, I can then integrate. I can know what u1 and u2 is, and I can do this. I'm almost done then, right? So here's how you use what we got there to get what u1 prime and u2 prime are. u1 prime, this is a part of Kramer's rule. u1 prime is the Wronskian that you get when you replace that divided by the full Wronskian, which would be negative y2 f of x divided by the Wronskian. Now, yes, sorry. Why is it so cool to know that y1 and y2 are linearly independent? They have to be linearly independent. If they weren't, then Wronskian would be 0 at least one place in your interval, and you would go to shit, right? That's a nice. Now this isn't why the Wronskian must be 0, but this is a consequence of the Wronskian not being 0 if they are linearly independent. It's a nice kind of tied up little piece of something. I don't know what the hell to call it. Shit. Obviously, I don't. And then the other one, amazingly enough, so I get y1 f of x divided by the Wronskian. And then once you get these, now here is what you need to memorize, right? It's built off the back of all this other stuff. So I assume this, I develop these, and then I integrate to get u1 and u2, and then I just throw them back in. So let me give you the handout that's got all that encapsulated. Not all this, my God, but all the important stuff. Oh, I didn't mean that. It's all important.
But some is important too.
So much more important.
It's like everyone's creating equal, but that's more equal than others, unfortunately.
Is that how the favorites are like?
One side of this is the 4-6 that we just did, and the other side is a little bit of a preview of 4-7.
So I'm gonna do the long way on the test since I won't remember the shortcut.
Oh, sure. Go with that.
Your guys.
That's what you're doing, right? Really small things.
I think you can do it. You got me, right?
And then you found out.
Did you just like Google like
Where do you think they put it?
I was like, I want to know how to